Hi and welcome everybody. Today is a really exciting day. Exactly 1 month ago to the date, we announced the collaboration between UPM Plywood, Arctic Astronautics and Huld to build the world's first wooden satellite. And today we are thrilled to show you how we are progressing towards the launch of the satellite. Our goal is to send a wooden satellite to space by the end of this year and to be the first in the world to do it. My name is Ari Voutilainen and we are broadcasting live from the Biofore House in Helsinki. WISA WOODSAT is a research satellite and it has a clear mission. We want to test if wooden materials can be used in space applications. The satellite is made of WISA birch plywood and we are testing the material by exposing it to extreme space conditions. This means extreme heat, freezing cold, vacuum and radiation. We are pushing the boundaries of forest-based biomaterials in an environment like no other. But of course that's not all. In addition to the material science mission, we have packed a lot of technology in the satellite. Today we have an opportunity to meet a part of the team that has developed WISA WOODSAT. First, Jari Mäkinen, Program Director from Arctic Astronautics. Sami Uuksulainen, Head of R&D from UPM Plywood. And Kevin Vainio from Huld, who has designed the camera boom for WISA WOODSAT. And as promised, we will, of course, today unveil the first WISA WOODSAT prototype. And during the broadcast, you can ask questions in the chat, and we will answer them after the presentations. But now I will give the floor to Jari Mäkinen from Arctic Astronautics. So, Jari, we announced our collaboration 1 month ago. So I think the question is that how is it possible to make a satellite in 1 month?
Well, in fact, first we got to think that we announced our collaboration 1 month ago, and of course the work has been started before that as well. So what we did first was that with Sami and his team, we verified that plywood in fact can be used in space. And the answer was yes. The most interesting question was outgassing, but Sami will tell a little bit more about that. But already before that, we have been thinking about the idea of sending wood to space, because wood is a really good material. It is just like a composite material, but forest-based. And so we had the idea of using wood in space, and then we had this one. So this is KITSAT. KITSAT is an educational satellite. It is 1U CubeSat. CubeSats are small satellites, so this is a real-sized CubeSat satellite. And also, this is fully functional satellite that has been made for students and everybody who wants to learn about space technology, so that they can build themselves a satellite, and after that they can test it and use it just like a real satellite. So basically, this one here as well is space capable if we just change some electronics inside and the materials and above all the solar panels and so forth. So this was already existing, and then when last December we heard about the plan from Japan to send a wooden satellite to space, we thought that okay, we have already wood, we have already almost like a satellite, let's make a project. And luckily UPM took the initiative and partially decided to finance our mission, and here we are now. And well, I think it is easier to explain about the satellite if we really unveil it. Should we do it now?
I think that's what we should do. So basically that's what everybody is here for.
Indeed.
So, ladies and gentlemen, the moment you have been waiting for, this is WISA WOODSAT.
So here we are. Isn't it beautiful?
So what can you tell about this satellite?
Quite a lot anyway. So this is our satellite. It is in real life so small. So the whole idea of these CubeSats is that they can be really so small satellites. You can put everything that is needed inside over there. And basically we have taken a KitSat, made it a little bit better. And you can see the electronics here. This is not really the final version of the electronics, but the looks is really the same. This is a prototype that we have used to find the best possible way to cut the wooden parts, and especially do the selfie stick and so on. But what is here? The most interesting thing is the research of the wood over there in space. So what happens over there? And therefore we've thought that we need some sensors over there. So inside over there we have a sensor suite, a little package of sensors made by the European Space Agency. So yes, we have a European Space Agency as a partner in this mission, and they will provide to us a very novel thing that is called quartz crystal microbalance. So yes, it is a balance. It is measuring the minuscule, very small amounts of gas that is coming out from this plywood inside over there, and therefore we can see how the wood is what's happening for the wood over there in space. And then the second thing that is really important is that we want to see what's happening over here, because over there in space you have ultraviolet radiation and so on, and therefore we needed some way to take photos of our satellite. And what was the quite obvious choice was that we need a selfie stick. But for the selfie stick, Kevin will tell a little bit more about that in a moment, but the challenge was to put it inside over here in this satellite. So when this is launched, the antennas are here and this little boom is over there. Then in space this will open and the selfie stick will open as well, and the camera will be over there, and with this camera we can take very good photos of the satellite in space, and we can see all the changes that is happening to the plywood surface. And therefore we have not only our logos over here, because when we see how the colors are changing, logos are really good. Of course we are proud of our product as well, and so on, but they have a function as well. And in addition we have a color calibration card over here, so that we can of course check that the colors are really good. And by the way, this is made by a Finnish paint company that is called Tikkurila. So we will have a really good and professional color chart over there. And what else? One interesting thing is this plywood. Sami, of course, will tell a little bit more about that, but what is really new here is that we are covering the plywood with the ALD, so atomic layer deposition. It is never used for the wood before, and therefore we have a very, very thin nanometer scale layer protecting the plywood, and one of the panels will be treated with the normal varnish, so that it will protect that, and we can see then what will be the difference between these two. And after that we have some other experiments, because this is a cheap and easy way to send something in space, and we had a little bit more extra space, and therefore European Space Agency, for example, will test 4-3 printed material. 4-3 printing means that it is 3D printed, but it behaves in a wanted way with the heat. So you heat it, and after that it changes its form, and we have this kind of little experiment over there and also inside over here, and that's also something that is quite new, and we will test it with this satellite. And another thing is a radio communication. We have, of course, a normal radio communication with the satellite, but we have the thing called LoRa, L-O-R-A, and it is a new way to be in contact with the satellite with a very, very inexpensive and small ground station. So this will be a radio amateur mission as well, so that the radio amateurs and people who will be radio amateurs hopefully in future as well can send messages over here to the satellite, and then they are relayed to other users. Plus this LoRa can be used also to download the pictures from the satellite, and also the radio connection will be used that. So basically, whoever has the equipment over there in ground, they can download the pictures from here. So these will not be protected photos. Everybody can take pictures of our satellite and check if the wood is behaving nicely. So basically, this is all. It is a very small package, but there's a lot of technology in there. And yes, oops, that was holding that over there. We don't need it anymore. And development is going on. And with this model, we are just testing that everything goes well. And if everything goes well, as we think, in end of this year, we have a flight model already ready. And it will be tested, it will be shaped, it will be made sure that it sustains all the stresses of the space mission. And the most interesting there is not only being in space, but the launch, because during the launch you have a lot of vibration and shaking and noise, and it is the most dangerous part of the mission. In fact, and for that wood is good. And Kevin and his team, they have made sure that this little selfie stick will support as well. That's all for now.
All right, thank you, Jari. That was a good overview of what kind of technology is on board WISA WOODSAT, so a lot in a small package. But now let's talk with Sami Uuksulainen, who is the Head of Research and Development at UPM Plywood. UPM has produced plywood for over 100 years, and we know quite much about the material science of wood and plywood in particular. But a satellite is not exactly an everyday case for plywood use. So I guess the question is, what kind of challenges does space pose to forest-based biomaterials such as plywood? And of course, how have we tackled those different challenges?
Thanks, Ari. Excellent question. And so our interest in this particular project, it is very interesting as a whole, but I think it's coming basically from the material science part. So UPM as a company is very known in wood chemistry, wood physics, and has a lot of knowledge about the wooden material. And also, when we have been delivering or manufacturing and developing plywood, let's say the past 100 years, so we also have a lot of knowledge about different end uses and what kind of environments on a ground level or on a sea level plywood has to withstand. But then now when we are entering the space, that's totally unknown area for us, and there's lots of questions. Because I think the playground is way different. So in ground level, you have this moisture level variation, temperature. Of course, we have also UV radiation, sunlight. But in space, you don't have a moisture involved. Okay, that's a good thing. But then the very high levels of UV radiation and other space radiation, that's an unknown area for us. So it's very interesting for us to see how the plywood will withstand those very harsh environments. So in that sense, there's a couple of things that we know, but there's lots of unknown, and basically how to tackle these matters. And as Jari mentioned, there will be rigorous testing, different kinds that we have been unable to access before this. So we gather lots of new data about our product and the material. But then again, something we can do by ourselves. So I mentioned the moisture, and that might cause a problem when you are in space, in vacuum. So to mitigate that risk, we have done already so that the samples that you have see here, These are the actual panels that are going to space. So these has been vacuum dried. So we try to take all the excess moisture out of the panels before they are further processed. And it was already mentioned that there will be this novel way of coating the plywood, the ALD coating and different kind of varnishes. So these are basically the kind of processes how we try to mitigate those possible problems. But as said, there's lots of unknown areas, and basically the space is our laboratory now. So it's very interesting to see what happens. But let's say so that the question is that what do we expect that will happen? Of course, the UV radiation will play a big role about the color changes in the wooden surface. But will there be this kind of decomposition or other things of deteriorations? That remains to be seen. But we believe that it shouldn't be that big. So I believe plywood will perform very well in this new environment.
How do you see the kind of basic things like heat and cold, which is the kind of first things that we mentioned in our teaser video? So
yeah,
what kind of problems they might be?
Let's tackle the cold first. So we have experience of end uses where there are extreme cold, like the LNG tankers. So we know that in those conditions, it's minus 163 degrees Celsius, and plywood is withstanding those quite harsh environments also for the tens of years. And also there is a very strong mechanical stresses involved as well. So plywood is a perfect material for those end uses. And heat also, if it's not, let's say, too excessive heat, if we think about the heat levels in ground level, no problems.
Yeah, so minus 163 is really, really chilly.
I would guess so.
Yeah, all right.
Something?
Yes.
Because we know that plywood is right now used also in aviation. So it is really a very good material. It withstands really nicely the vibration, and from our point of view, it has been really interesting to see how we need to work with the plywood, how we can saw it, how we can do the holes, and basically how basically these are CNC machined, all the parts over here. So how we operate the machine so that we keep the good behaviors of the plywood and try to avoid then the negative sides. But indeed, from our point of view, up to now, this is really like a composite material with the good things and the bad things. But the good things seems to be much better than many people have been before thinking. It is just like steel. Previously, everybody said that steel is not really good material for the spacecraft until Elon Musk decided to do their Starship from that, and now everybody thinks that okay, it might be in fact good. And I'm not seeing a lot of use for plywood in space, but in special applications, yes.
Yeah, as you mentioned, the versatility of the material. So we are always discussing about strength to weight ratio, and for plywood that's ultimate compared to the competing materials. So it's lightweight but yet strong for the applications that we are using. So very, very good versatile material.
Absolutely.
Thank you, Sami. Material science is a very interesting topic, and as you said, this is a project where we are really pushing the limits and boundaries of forest-based biomaterials. But let's take a little bit sort of a different view and talk about something which is very unique to our satellite, which is the selfie stick. So we have a satellite with a selfie stick. And Kevin Vainio from Hult, can you tell us a little bit more about the camera boom and the design and manufacturing process for that?
Sure. Yeah. It's an additively manufactured selfie stick headed to space on a wooden satellite. can we get more 2021 than that, really? As I mentioned, it's additively manufactured, so it's using a technology called laser powder bed fusion. There is a vat that has powder in it. A powder layer is added thickness of between 0.04, so 40 microns or 80 microns at a time, and a laser then melts this cross-sectional area of the part that we desire. And the big advantages with additive manufacturing is we can get to a near net shape, and the material usage and energy usage is very small, far exceeding what could be done with, say, machining. So we have a subframe in there to support this. Jari, if you sort of can see something in there, but to support the lower payload, so this selfie stick, and it's fairly sizable. It's 10 centimeters by 10 centimeters, about 30, 40 centimeters, or 3 or 4 centimeters, excuse me. And to machine that out of a single block would take time, and the excess material is obviously waste. But here, it's built out to the net shape, and we're losing only about 0.5 to 1% of the total mass with machining to this part, which is it's fantastic. We're using materials responsibly, effectively, efficiently to manufacture these parts, and especially some of the geometry we have in the part is fairly complex. So the housing for the camera module, manufacturing that in any other way becomes, it's not as trivial for sure. So it's 3D printed, then a bit of machining to get screws in, lenses in, that sort of thing. And I definitely have to thank all our partners involved here and the team responsible for all of this work, Jaakko and Topias and obviously Matti and Kimmo from space side, and everyone else from Huld that's been involved in this. We've been working on the design, and immense challenges to conquer. The fact that we're in space, the fact that we can't just walk over to it and restart it if something happens. We have to have a high level of redundancy and to make sure that the mission succeeds. And so things we've had to take into account is cold welding, how aluminum attached to aluminum, if there's any, as I mentioned, cold welding. So what can happen is in the vacuum of space and the temperatures that we encounter there, it can fuse together, and then we are not able to open up that boom anymore. So we have special coatings in there. It'll be anodized, and we'll have the same ALD coating that will be on this WISA plywood panels, actually on the 3D printed parts, to make sure that we have good surfaces that allow for a smooth transition from stowed to deployed, so we can get great images. And the manufacturing has been done by Delva Oy, not far from here, with state-of-the-art machines, and they have Nurmilo machining company helping out with all of the machining. It's been fantastic to work with them. And yeah, we still can't believe we get to work on a project like this with such great companies, Arctic Astronauts and UPM. I think we're setting a new standard for CubeSats with this project.
May I add something? So that the challenge here was indeed that everything here got to be packed down here in a very small and limited space over here. And I got to say that when we realized that we need a selfie stick for the camera, of course we laughed first because, well, selfie stick and so on, but that's what we needed. And then that was in February when we started to think about this. Our company has some experience with wood, but about the satellite, but with the mechanics we don't have any experience. Then I called basically to Huld and said that listen, that we need a selfie stick, and soon. And it was sort of funny that they figured out how it can be done very soon, and here we are. We have now a Flight 30 version already here.
Yeah.
So congratulations from our side already now.
Yeah, and that's one of the great advantages of additive manufacturing is we have a really quick turnaround. We're not tied down to machining paths and things like that. We're able to produce a shape in our CAD, send it out to Delva for manufacturing. They can turn it out overnight, get it machined and shipped out to us, which again, if we had those machined out of a block, weeks possibly for a part turnaround.
And good thing with this is as well that yes, we are wooden satellite, but of course we need some metals over here. You cannot replace electronics with wood, that's sure. And then for this kind of structure, wood is not really good for that. So for this we need metal, but with addition AM, we can have as little as possible. Yeah. So it is really efficient, really nice.
Maybe the next step is then a plywood selfie stick.
Oh, yeah. It got to be a little bit bigger, I guess.
Yeah, maybe.
All right, but it's a lot of technology and a lot of effort packed in a really, really compact package. And it's really interesting to see how it sort of is getting that kind of companies together to innovate on a project like this. And what else to mention is that I think greetings to Savonlinna, to our Savonlinna plywood mill, where actually Jari was there to witness the manufacturing of those panels, and then our Lappeenranta laboratory, who's been helping us with the drying of the panels, so that there's a number of teams also from UPM side who have been working on this, and more to come.
And big thanks to you already now as well.
Yeah, thank you. I think the next thing that we should do is that looking to the chat and see what kind of questions are coming from the audience, and there are already some. So basically what you can do is that if you go to the live chat and ask your question there, I can ask them then in the studio from our experts. So let's start from the first one. There is Onkar Batra asking, can we use WISA plywood in our KitSat as a surface protection to launch our KitSat in LEO in future time?
New low Earth orbit. So what was the question? It was...
Can WISA plywood be used as a KitSat cover?
As a KitSat cover, so basically using...
Can you change the panels?
A normal KitSat, in principle you can do it, yeah, no worries, but normal KitSat is not really space capable. I think that it will work for some time if you take GIS satellite and send it up there, but the electronics is not really good for that. So that a little upgrade, you can use this as well, but definitely you got to replace the panels. And why not? If there is interest for that, we can produce also the plywood panels for standard KitSats as well. No worries. And possibly far away. So low Earth orbit is very nice place, but I think that plywood will just support quite well the conditions a little bit far away as well.
Yeah,
indeed.
When we're talking about the wood, there are a couple of other questions. Is that tell us more about the protecting layers, please?
Well, the protecting layers, basically what we are, the most interesting here is ALD, and ALD means atomic layer deposition, and it means that we are putting, we are machining the parts in dry like this, and after that we are packaging the parts dry like this, then they will be machined with the CNC machine, and after that they will be packed again in vacuum, and they will be shipped to Picosan, that is a company here in Finland as well, who is specializing in ALD. In fact, they have developed this technology that got a Millennium Prize also a couple of years ago. So it is a really nice technology. You put the object in there. It has never been used for the wood before, so it is new for them as well, but you put it in a vacuum chamber, and after that you layer basically very thin layer of atoms. In our case it is aluminium oxide, and it will be nanometer scale layer of metal over here, and after that you cannot see it, but it is there. It is basically encapsulating the wood inside, and that that's something that is really interesting. Another experiment that was our original idea was to use just a normal varnish. How do you pronounce it?
Varnish.
Varnish. So varnish and we will have one experiment with that as well. It is a special varnish coming from Tikkurila as well, but I think that this ALD will be extremely interesting because it is clearly much better and something that is totally new, possibly for you also in future.
Yeah, it's very interesting.
All right, then there's another question related to the plywood gluing from Aki Karjalainen. What kind of glue has been used in this kind of plywood?
So yeah, good question. As I mentioned, this is standard product, so standard plywood glue, so phenolic resin. But in this particular plywood that is produced in Savonlinna, we are utilizing this biobond technology. That means that in the resin manufacturing, the 50% of the phenol is replaced with lignin. That is actually a byproduct of our UPM's own processes. So we utilize these chemical building blocks in our products nowadays, and by that we are creating more sustainable products. But standard glue, standard plywood.
So basically you can buy normal sort of space grade plywood from the hardware store.
As said, it's just normal plywood. There are no tricks
Yeah.
in the actual product. It's just normal plywood.
Right.
Basically, we have just selected the best possible parts from standard plywood.
Standard panel, yeah.
All right. Then there is a question about the LoRa frequency. So what is the LoRa frequency band that is going to be used? Do we already know?
In fact, I got to say now that I don't remember now the frequency, but there is already now a little bit information on our website about this LoRa, and afterwards we can send a little text, a message about this, because our specialist who knows everything about this LoRa is backstage over there. So after this broadcast, we send a little bit more information about that.
And also we have a blog where we actually then explain how you can build your own ground station later on, so that closer to the actual launch, so that how you can build your own and what do you need to kind of communicate with the WISA WOODSAT.
Exactly. This LoRa is, in fact, it is really interesting radio amateur experiment, and it will be accessible for everybody all around the world, and we look really forward to that.
Then we have a good question from a named Traveler. So how are we going to get it, up in the space?
With rocket.
From the disk? With a rocket.
With the rocket.
Tell me more.
Just simple as that. So nowadays with this kind of CubeSats, it is so easy because these are standard satellites, and you can basically call the rocket companies who are launching the satellites to space, or the dealers who in between. So they are brokers who buy this kind of slots for these satellites, and we made our round also in earlier this year to check what are the best. Well, it is beeping, so I put it off. So we checked what kind of possibilities we do have, and when considering a rocket launch, there are several factors to consider. One is price, and the second is time when you can launch it. Then the orbit as well. Our satellite will be on a polar orbit, so SSO, solar synchronous orbit, and because we want it so that it is it goes around the whole world, and everybody can be in contact with that, and also because Finland is quite up here, we want to have a good passes over Finland as well and be in person in contact with that. And finally, when considering all the aspects of the launch, we ended up to have a deal with Rocket Lab. Rocket Lab is a US-based company that is building Electron rocket that is launched from right now from New Zealand, from Mahia Peninsula. Later they will launch also rockets from US, but our launch base is over there in New Zealand. And Electron is really interesting rocket. It is a little bit smaller than others. It has just a couple of satellites over there. So when comparing to other launchers that are used usually for the CubeSats, they are like buses, but we are riding a taxi, and it provides for us a very smooth and nice ride to space. And because our mission is also to share all information about the satellite, how it is made, and how we prepare the mission, we can follow it quite nicely with Rocket Lab as well. They have been already up to now a very good partner for us, and it is later this year. We are targeting to end of this year for launch with rocket with Electron rocket from New Zealand, and yeah, so that's our ride. And there will be some other satellites also sharing the ride with us, but the ride up will be quite fast. It is just 8-9 minutes from the launch, and then we are up there in orbit.
How high is it, by the way?
500
500 kilometers, so quite high.
Yeah. Exact height will be decided with other passengers of the flight later, but about 500 kilometers. Yeah. So it is not really so high, but it is nicely high, but not too low orbit for this kind of satellite.
Yeah. Actually, in the chat, Samuli Nyman is sort of giving us a bit information about the LoRa frequency, so that it says here that LoRa is used at 70 centimeter frequency, or 435 to 438 megahertz. And the exact frequency will be known closer to launch, so that basically how we tune it closer to the launch.
And I got to say that Samuli is our head engineer, so that he knows everything about this satellite.
Right. All right. I think those are pretty much the questions that we have at the moment in the chat. But one thing that I need to ask, which is something that every time we start talking about it, there's one question. Is it real?
Yes, it is real. It's a real thing. So first of all, this is real. We have been flying this kind of satellites to stratosphere already, and it is supporting it quite well. And our team has a background at Aalto University with the Aalto 1, Aalto 2, Aalto 3, and Fossil and Suomi 100 satellites. So we have been dealing a lot with the satellites already, and this one here, it is not a gizmo. It is not a well, it is a mock-up right now, but it is a fully functional mock-up already now. So we just make the final version is exactly like this, and yeah, it's real. You can touch it. Yeah. Well, not right now because of the corona restrictions, but this is a real thing.
Yeah, then there are sort of one additional question is that what is the satellite's expected lifetime and what happens with it afterwards? So what happens when it...
We plan a mission of two years, so that we are happy if it functions for 2 years. These kind of small satellites, they do have problems like radiation, for example. You can have a cosmic ray on a wrong time, on a wrong place over there, and it is dead right away. So we cannot really make sure that it supports everything like that. But when thinking about the other satellites, like the Suomi 100 or Finland 100 satellite that is now around the world, that is exactly like this size, it has been running quite well, more than 2 years already now, and we expect that this will function more than 2 years. The most interesting part of the mission is let's say 4-5 months from the launch, because that's the time when the majority of the outgassing of the panels will happen. And that's the time when we basically are operating the satellite all the time and try to get a lot of information. After that, we will operate it a little bit more automatic way, and we will announce every now and then when the satellite is going over to your place with some local activities, so that people can download the pictures and be in contact with the satellite. And LoRa, of course, it is something. It is free for the radio amateurs basically all the time for that 2 years, and if the satellite is functioning well, it will go on. Of course, after that, we are not switching it off when it is over there. Right. But finally, when this is up there in space, it will come back towards Earth gradually, because you have a little bit atmosphere up there in 500 kilometers as well, and it slows down the speed, and therefore it is coming down faster when it is lower, and finally it will it will plummet to the atmosphere and be burnt over there. So basically, if you remember now, the Chinese rocket stage that collided with Earth had a re-entry now during the last weekend. It will happen exactly like that with this, except that this will totally burn already up there in 80 kilometers, I think. And that's one thing, the plywood will burn 100% sure quite fast. So it is much better in that sense than aluminium. But these kind of satellites, they will burn over there without any problem anyway.
All right, and I think that we can close with the final question is that what tasks are going to be completed by WOODSAT in space, and how long will WOODSAT be serving?
Well,
we asked about answered the service time, but sort of what kind of missions do we have?
Well, basically we will operate all these instruments that I mentioned already earlier. So what happens when it is up there in space? Of course, we operate everything in parallel because we don't have so much electricity over there, and we take photos every now and then. And we have also another camera back there so that we can take the selfies and then Earth views through this little hole over there, and those will be done according to the timetable that will be decided later when we know our rotation and everything. But then with the European Space Agency instrument kit or the sensor kit, we will operate it very regularly also in the beginning of the mission and take the measurements about the conditions over there. And then the ESA 4D printed parts, I don't know exactly when those will be triggered and used, but those will be done also during the first months over there. So basically what we do in space, we take selfies and the other photos, we take the measurements, and then this LoRa will operate all the time. And every now and then we have special campaigns so that people can be in contact with the satellite and download the pictures. And we will announce those times later when we know exactly what is our stage.
Yes. All right. Thank you for all of the questions. And if there are some unanswered ones, I'm sure that we will come back to those in our blogs and in our social media channels later on. Talking about those, you can find us from the web at wisawoodsat.space. And you can also follow us on Instagram and Twitter with the handles at @WISAWoodsat and with the hashtag #WISAWoodsat. And actually, if you now go to the wisawoodsat.space website, there is a little present for you. You can actually download a couple of WISA WOODSAT posters, which you can print at home and decorate your office if you are into space things like we are here. So thank you very much for joining us today. And as said, our goal is to send a wooden satellite up to space by the end of this year and be the first one in the world to do it. So goodbye from the Bio4 house. See you in space.